This is everything you need to know about prompt engineering. If you're not familiar with the term prompt engineering, it's a bunch of awesome strategies to get the most out of your artificial intelligence. So Google put together this prompt engineering guide. I'm gonna go over it. We're gonna go more in depth. And by the end, you are going to be a master prompt engineer. So the very basics, when you're chatting with a model like ChatGPT, like Gemini, like Claude, you're typing in some input in natural language and then it gives you an output, also usually in natural language. And the way that these models work is by taking your input, whatever your prompt is, and predicting what it thinks the output would be based on your prompt. So your prompt really matters, how you structure it, what words you use, examples you give. All of these things are prompt engineering. And there are a number of tried and true prompt engineering strategies, which also depend on which model you're using, how good it is, what's the token limit, and we're gonna go over all of that. So remember how an LLM works. It's a prediction engine. The model takes sequential text as an input, your prompt, and then predicts what the following token should be based on the data it was trained on. And a token, if you're not familiar, is basically just a word. It's usually 3/4 of a word. We're not gonna get into too much technical detail about it, but just think about it, token equals word. And so the model's trying to predict the next token is added to the initial prompt, and then it tries to predict the next token after that, including based on your original prompt plus the additional token. And it does that over and over and over again until it thinks it has produced the proper output. Prompt engineering is the process of designing high quality prompts that guide LLMs to produce accurate outputs. That's a great definition for it. And if you've ever prompted a large language model, found that it didn't give you exactly what you wanted, changed your prompt, and then it did, that is prompt engineering. So before we get into the specific prompt engineering strategies, let me go over a few basic terms. Every large language model is different. Some are vastly different, some are a little bit different, and each of these differences matter. Setting these settings correctly will also help you get the most out of your prompts. So first, output length. Output length is the maximum number of tokens a model should output in response to your prompt. The longer the output length, the longer the response might be to your prompt. Now, if you just ask what's 2 plus 2, it's not going to spend paragraphs and paragraphs of text explaining to you the answer because the answer is simple and short. But if you ask it for code, this output length setting might make a big difference. Now, if the model's outputting more tokens, that potentially costs more money, takes longer, and uses more energy, more electricity. But here's an interesting nuance to keep in mind. Reducing the output length of the LLM doesn't cause the LLM to become more stylistically or textually succinct in the output it creates. Instead, it just causes the LLM to stop predicting more tokens once the limit is reached. If you set the output length really short, it's not going to give you shorter, more succinct answers. It's just gonna stop outputting once it reaches that limit. Let me show you an example. So here's Google AI Studio. Here is the output length setting right here. Right now it's set to 65,000 tokens. Let's set that to 5 tokens. So I say, write a story about a panda bear. I'm using Gemma 327B, which is a non-thinking model. And it just says the bamboo whisperer. Doesn't even make sense. And that is a maximum of 5 tokens. Now, let's say we move it up to 50 tokens. Let's give that same prompt again. And here we go. So the bamboo whisperer, and Lynn was not like the other pandas at the Misty Peak Reserve, and so on. And then it finally just stops right here. He didn't just taste the. So that was a maximum of 50 tokens. And of course, if I set it to 5,000 tokens, it's going to finish the story. But you can see here, it didn't write a succinct story. It just stopped outputting. So that's really important to keep note of. The next setting is sampling controls. Now here's the gist of how large language models predict the next token. LLMs do not formally predict a single token. Rather, LLMs predict probabilities for what the next token could be, with each token in the LLM's vocabulary getting a probability. So if you say the cow jumped over it doesn't just predict moon. It'll give a probability score to every single token in its vocabulary. And the one with the highest probability is the one that you see. And there are three main settings within these sampling controls: temperature, top K, and top P, and we're going to go over all three of those. Now, personally, I think temperature is probably the most important setting within sampling controls. Temperature controls the randomness in token selection, but really a more simple way to think about it is the higher the temperature, the more creative or unique the responses will be. The lower the temperature, the less creative it'll be. So once again, write a story about a panda bear. We have temperature set to 1, so that is the most creative. Let's give it a try. Okay, so we got an output. The rain in bamboo forest wasn't just a drizzle, it was a deluge. So let's stop there and let's give the same prompt again. Let's see what happens. So the same exact model, the same exact prompt, and as you can see, a completely different story. Now, what happens if I set the temperature to 0? Let's see. I'm gonna give it the same prompt again. Write a story about a panda bear. The bamboo forest hummed with the gentle rustle of leaves and the chirping of unseen birds. Great. Now, let's do it again with temperature 0. And look at that. The bamboo forest hummed with the low thrum of cicadas. So very similar to the previous one with a temperature of 0. And that's what you're gonna get. You're gonna get very different responses every single time you give the same prompt when the temperature is really high, and the opposite when it's very low. You're gonna get very consistent responses. So remember to adjust your temperature dependent on the use case that you are doing. All right, next, top K and top P. Now, to be honest, I don't really use top P and top K settings at all. I use temperature and that's enough for me. But let me just briefly go over what they are. So top K works very similarly to temperature. Top K sampling selects the top K most likely tokens from the model's predicted distribution. And the predicted distribution is just the vocabulary set and the assigned probabilities. So the higher the top K, the more creative and varied the model's output. The lower, the more restive and factual. So very similar. Just another setting to play around with for creativity. Top P sampling is a way to limit the set of vocabulary that the model will choose from based on its cumulative probability. And don't worry if you don't understand that. Honestly, I rarely ever use top P. It's just good to kind of generally know what it does. So play around with those three settings. Now in this document, they give suggested starting points for all three of these settings. And generally, within whatever chat interface you're using, they give you their default settings as well. But for here, as a general starting point, a temperature of 0.2, that's actually a lot lower than I usually start at. I usually start at like 0.6. Top P of 0.95 and top K of 30 will give you relatively coherent results that can be creative, but not excessively so. If you want more creative results, raise the top P and raise the top K. And obviously, if you want more consistent, less creative results, do the opposite, drop those settings down. All right, now what you came here for, prompting techniques. Now, the first thing we're going to talk about is general prompting or zero shot. If you've heard of zero shot, it doesn't mean giving the model one try. It's a little confusing in that way. Zero shot, the shot term means how many examples are you giving the model? So with zero shot, it's the simplest type of prompting. You're not giving the model any examples of what you want as the output. So with zero shot, you're basically just providing a description of the task you want accomplished, whether that's write a story, do some math, write some code, but nothing else, just a thorough description of what you're looking for. Typically, the more examples you need, the more complex the task that you're asking the large language model to accomplish for you. So if it's a pretty simple task, like writing a story, you probably don't need a bunch of examples. So here's an example of a zero shot prompt. We are asking the model to classify movie reviews as positive, neutral, or negative. And here's the review. Her is a disturbing study revealing the direction humanity is headed if AI is allowed to keep evolving unchecked. I wish there were more movies like this masterpiece. Sentiment, so that's what we're asking for. What is the sentiment? And use positive, neutral, negative. And it got it right. Perfect. Now, for more than zero shot, one shot, or few shot, that just means giving the large language model more examples to work with. One shot means giving it one example, few shot means two or more. Now, with one shot, the model's gonna try its best to mimic whatever example you give. And when you use few shot, you're giving the model more chance to get the desired pattern correct from your example. So if you want the output in a specific format, that's a great way to do it. The number of examples you need for few-shot prompting depends on a few factors, including the complexity of the task, which we talked about, the quality of the examples. If you have great examples to give, then that just makes the job of the large language model that much easier, and the capabilities of the generative AI model you are using. As a general rule of thumb, you should use at least 3 to 5 examples for few-shot prompting. So let's look at the example they give in this document. The goal is to parse pizza orders to JSON. Here it is. So here's the prompt. Parse a customer's pizza order into valid JSON. Example, I want a small pizza with cheese, tomato sauce, and pepperoni. Now, if we give that exact prompt with nothing else to the model is going to infer what the structure of the JSON object should be. And the problem with that is if we do this 1,000 times with 1,000 different orders, we might get different JSON object structures. But if we provide an example like here, we want size, type, and ingredients, and within ingredients, we want an array of ingredients, then the model is going to be much more likely to use this exact structure. And here's a continuation of that same prompt. Example, can I get a large pizza with tomato sauce, basil, and mozzarella? So size, type, ingredients, right there. Now I would like a large pizza with the first half cheese and mozzarella and the other tomato sauce, ham, and pineapple. JSON response. This is where we're asking for the output from the model. So size, type, ingredients, and it's the same exact structure that we used in the examples. So this is a great use case for few-shot prompting. All right, next, let's talk about the system message, contextual prompting, and role prompting. The gist of what these things do is essentially getting the model to act as some role. So act as a senior developer, act as a CEO, act as a teacher. As soon as you give it that role description, the model will start taking on the behaviors and qualities of whatever it thinks that role would be. So first, system prompting. It sets the overall context and purpose for the language model. It defines the big picture of what the model should be doing, like translating a language, classifying a review, etc. So if you look at Google AI Studio, there's this little clipboard right here and it says system instructions. That's the same thing as system message. If you click it, this is where it says optional tone and style instructions for the model, which is where you would describe kind of the overall theme of what you're trying to accomplish. Next is contextual prompting. Contextual prompting provides specific details or background information relevant to the current conversation or task. It helps the model to understand the nuances of what's being asked and tailor the response accordingly. So in the document, they give this example. Here's the context, contextual prompting context. You are writing for a blog about retro 80s arcade video games. Then the actual task suggests 3 topics to write an article about with a few lines of description of what this article should contain. So in the actual task, it doesn't say that you need to write a blog for a retro 80s arcade video games, but that's in the context. So if we run it, here we go. The Unsung Heroes 5, From Pixels to Power, Coin Op Culture Clash. So you're separating the context from the actual task at hand. And last, role prompting. Role prompting assigns a specific character or identity for the language model to adopt. This helps the model generate responses that are consistent with the assigned role and its associated knowledge and behavior. Where I see this most of all is in agentic frameworks, specifically Crew AI. And Crew AI actually does a good job of taking this a step further. And they have a bunch of data to support doing this. And this strategy works just the same in direct large language model prompting. So look at this. Here's a role attribute that you can use in your agent definition. Defines the agent's function and expertise within the crew. It also has the goal or the task, the individual objective that guides the agent's decision-making. And it even has a backstory, provides context and personality to the agent, enriching interactions. So role prompting is very, very powerful. Now here's another example from the document. I want you to act as a travel guide. I will write to you about my location and you will suggest 3 places to visit near me. So the actual role is travel guide. And the task is suggest 3 places to visit. So here's my suggestion. I'm in Amsterdam and I want to visit only museums, travel suggestions. Let's run it. And here we go. So I'm ready to be your Amsterdam museum guide. Based on your request, here are 3 museum suggestions. So that is when role prompting becomes really powerful. All right, next is one I had not actually heard of. It's called step back prompting. And it's akin to a few other prompting techniques that I know of, but it's kind of unique. Let me show it to you. So step back prompting asks the model to first consider a general question related to the specific task at hand, and then feeding the answer to that general question into a subsequent prompt for the specific task. If that sounds confusing, I'll show you an example in a moment. So what is the point of that? It allows the LLM to activate relevant background knowledge and reasoning processes before attempting to solve the specific problem. By considering the broader and underlying principles, LLMs can generate more accurate and insightful responses. It encourages the LLMs to think critically and apply their knowledge in new and creative ways. It changes the final prompt doing the task by utilizing more knowledge in the LLM's parameters than would otherwise come into play when the LLM is prompted directly. So fascinating. All right, so first, here is an example default prompt. This is not step back prompting. So write a 1-paragraph storyline for a new level of a first-person shooter video game that is challenging and engaging. And remember, this is standard prompting, not step back. Let's hit enter and see. Okay, so the ravaged, derelict space station Icarus has become a deadly labyrinth. A colossal gravitational anomaly has ripped the station apart, and so on. So pretty good. And what it says here is very interesting. It's something that I come across all the time. Whenever I'm asking a model to do something really creative for me, it tends to give me like really generic responses, even when I set the temperature to 1. So creative writing is one of the things that I actually least go to large language models for. So going forward, I'm going to try this step back method. So now instead, let's get it to think about this topic space before we actually give it the assigned task. So based on popular first-person shooter action games, what are 5 fictional key settings that contribute to a challenging and engaging level storyline in a first-person shooter video game? All right, so it gave me a very robust answer of 5 fictional key settings. So now I copied all of this output and I said, here's the context, and I pasted it in. And at the very bottom, I say, take one of the themes and write a 1-paragraph storyline for a new level of a first-person shooter video game that is challenging and engaging. And let's see what it does. The player finds themselves in the heart of the derelict space station, having just emerged from a terrifying zero-G section filled with swarms of rapidly evolving nanobots. So just a good way to get more accuracy and more breadth of knowledge from your large language model. All right, next, for the prompting technique that really changed large language models completely, chain of thought. Now, before I get into this, chain of thought is being built into many of these models today. Anytime you hear about test time compute or inference time compute, this is what they're talking about. The models output their thinking in the form of chain of thought in the thinking section of its output before giving you the actual output. But before these were built into the models, we were prompting the models to do this in the kind of standard output. And it's actually quite simple, but really powerful. Now, if you remember back to my model benchmarks from, let's say, even 6 months or a year ago, I would append all of my prompts with think step by step and show your work step by step. And just by adding that to the prompt, we got much better, much more accurate, higher quality outputs from the model. Now, as I said, a lot of models come with this baked in, but not all of them. Any model that is on the smaller side or doesn't have a thinking mode or test time compute mode, this is still a very powerful prompting method. Now, it's funny because most recent models actually do this by default, even if they're not a quote unquote thinking model. Let's take a look. So this is Gemini 2.0 Flash Lite. This is not a thinking model. Here's the prompt. When I was 3 years old, my partner was 3 times my age, so 3 versus 9. Now I am 20 years old. How old is my partner? So here's how to solve the problem. Find the partner's age, so it is thinking step by step. And the answer is 26, and that is correct. Now, if we look at the example in the document, now the output did not show its work, and thus it got 63 years old. And so that's wrong. But when they asked think step by step, it actually output each step of the thinking and was able to get the correct response. And so anytime you have a smaller model or an older model, and by the way, you should still use those models for specific use cases, like when inference speed is important, when cost is important. There are many considerations when choosing the right model. And you can get a lot out of these smaller, let's say less intelligent models simply by using some of these prompting strategies. And not only that, you can combine prompting techniques. So you can take one shot or few shot prompts and mix it with chain of thought. Let's look at that example. So question, when my brother was 2 years old, I was double his age. Now I'm 40. How old is my brother? Let's think step by step. And then we give it an example. Here's an answer. When my brother was 2 years old, I was 2 times 2 equals 4 years old. That's an age difference of 2 years and I am older. Now I am 40. So my brother is 40 minus 2, 38 years old. The answer is 38. Then let's ask the question. When I was 3, my partner was 3 times my age. Now I'm 20. How old is my partner? Let's think step by step. And it basically mimicked the exact same thinking as the example we gave it. And chain of thought is really powerful for a lot of different use cases. Basically anything under the category of STEM, science, technology, engineering, and math, chain of thought is very, very powerful. But also logic and reasoning. And there are just so many different categories in which letting the model think step by step improves their output greatly. All right, next, let's talk about self-consistency, which is another very powerful prompting technique. So LLM's ability to reason is often seen as a limitation that cannot be overcome solely by increasing model size. The model can be prompted to generate reasoning steps like a human solving a problem. However, chain of thought uses a simple greedy decoding strategy, limiting its effectiveness. And greedy decoding just means picking whichever token is the highest probability token. And according to the document, it limits its effectiveness. Now, in comes self-consistency. Self-consistency combines sampling and majority voting to generate diverse reasoning paths and select the most consistent answer. What that basically means is running the same prompt against the model, let's say 5 different times, and then using the model to vote on whichever one it thinks is the right answer or the best solution. And it improves the accuracy and coherence of responses generated by large language models. All right, so let's look at an example. We have a task to classify emails by either important or not important. And here's the email. Hi, I have seen you use WordPress for your website, a great open source content management system. I have used it in the past, and so on. Here's the important part. I did notice a bug in the contact form, which happens when you select the name field. And so this would be an important email. Somebody's contacting you about a potential bug. So classify the above email as important or not important. Let's think step by step and explain why. So here's the output. Step 1, identify the purpose. The purpose of the email is to inform the recipient of a bug in the contact form. Step 2, assess the potential impact of the bug. Step 3, consider the credibility of the sender. Conclusion, important. Great. Based on the potential impact of the bug and the credibility of the sender, the email should be classified as important. The recipient should take immediate action to fix the bug and protect their website from attack. Now, let's look at the second output. So again, we're prompting the model multiple times, and then we're going to have the model decide which output is best. So output 2, lack of urgency, non-critical bug report, lack of personal impact. Absence of action request and sender's intent. Conclusion, not important. And for attempt 3, it deems it important. So 2 out of 3 outputs from the large language model deemed it important. And so you can do this 3 times, you could do this 5 times, you could do this 50 times. And then you basically take whichever output or whichever response happened most often as the truth or as whatever the best response is. So in this case, 2 out of 3 were important. Let's classify it as important. But it comes at a big cost. Obviously, if you're running these prompts multiple times for every single task, there's a high cost, there's high latency. And so just something to keep in mind as you're deciding the trade-offs of using this prompting strategy. So now that we're familiar with chain of thought and self-consistency, let's talk about tree of thoughts. So it allows LLMs to explore multiple different reasoning paths simultaneously rather than just following a single linear chain of thought. Here's what it looks like. So here is chain of thought input, the different steps, and then the output. But here is tree of thought. You have an input, and then it tests at each step different outputs that lead to the next set of outputs that finally lead to the final output. And this is using a combination of self-consistency and chain of thought. So you can imagine it like this. We have an input, it comes up with the first step, multiple first steps, and then you have it decide which one is most accurate or best. Then it goes on to the next one and does it again and again and again until you finally get the final output. Now, with Tree of Thought, doing this strictly between just a user and what you can type into a prompt box to the model is not really viable. There's just too much going on. You really need to implement Tree of Thought with code or use some kind of framework to do it for you. And this approach makes Tree of Thought particularly well suited for complex tasks that require exploration. And so if you have more complex tasks, more sophisticated tasks, Tree of Thought might be great for you. All right, next, let's go over React. That is reason and act. Reason and act prompting is a paradigm for enabling large language models to solve complex tasks using natural language reasoning combined with external tools, search, code interpreter, etc. Tools are incredibly important for taking the raw intelligence of a large language model and allowing it to accomplish real-world tasks. React mimics how humans operate in the real world. You can kind of think of React as agents. Basically, you have the logic, the core large language model, and then you give it tools. Tools to get new knowledge, or tools to save memories, or tools to communicate with other agents, basically anything you want. React prompting works by combining reasoning and acting into a thought-action loop. The LLM first reasons about the problem and generates a plan of action. Then it performs the actions in the plan and observes the results. Now, if this sounds familiar, a lot of the frontier models nowadays have this built in. You can check on and off different tools, and it has chain of thought built into its thinking mode. So here's Gemini 2.5 Pro preview as of May 6th, and here are its tools: structured output, code execution, function calling, Google search. And so this is a perfect example of React being done for you. But of course, when you're using the cutting edge models, you're also paying the most and you're probably waiting the longest. So highest cost, highest latency. But you can get a lot of these benefits on older, or let's just say smaller, faster, less intelligent models simply by using the React framework. So React is really just an agent. And in this example, you're seeing the very basic version of this. So here's some Python code. We're loading LangChain's agents. Here's the prompt. How many kids did the band members of Metallica have? Now, here's the LLM. We're using Vertex AI, which is Google's product. And we're using the tool SERP API, which is a Google search API, giving search, web search, available as a tool to the models. So we run it, and that's fine. Now, given these few lines of code, we've now given the LLM the ability to plan, to execute, to review what happened, and then execute again if it needs to. So here's the output. Metallica has 4 members, so let's do a search. Here's a tool called search. Action input: how many kids does James Hetfield have? Observation: 3 children. Thought: Metallica band members have 3 children. Let's do another search. Lars Ulrich, Kirk Hammett, and so on, all the way down. So it does one search per band member, finds the total number of kids, adds them all together, and that's the answer. And yeah, this is really just agents. And 9 times out of 10, there's no reason to write the agentic framework yourself. You can take LangChain, you can take Crew AI, and they do fantastic jobs of putting these frameworks together for you. All right, so all of these prompting techniques can obviously get very complex and tedious and take a long time for you to write manually. But what if you can have AI write the prompts for you? This is something I do all the time. This is called automatic prompt engineering. Let me tell you how I do this. So I'm frequently asking large language models to write code for me, but I also don't want to write a very detailed PRD, which is just a list of requirements for the code that I want written. So what I do is I'll just come up with a few sentence description of what I want built. Then I will ask the model to write up a PRD for me. Then I take that PRD, put it back into another model, and I say, write code based on this PRD. And so it does the job of writing extensive detail for whatever I want built. So it's a good way to add a lot more detail to whatever prompt you're writing. But you can not only do that, you could take any of the prompting techniques we've talked about today and simply say, here's my most basic prompt, do chain of thought with it or do self-consistency with it. And it will write the prompt that you can then put back into the large language model to actually do that prompting technique. All right, so next I want to talk about a prompting technique that I use that I'm not even sure what it's called, but it's basically deciding when to ask the model to write and execute code for the prompt for the solution versus just give you the natural language solution. All right, so let's use a prompt test that I used to do all the time, but now all the models get it right. So this is GPT-4o, and it says how many R's are in the word strawberry. Now, it did get it right. There are 3 R's in the word strawberry, but frequently other models would get this wrong. So here's a different way to think about it where you're always going to get the right answer. Many models have the ability to write and execute code. So rather than just me saying how many R's are in the word strawberry, I'm going to explicitly tell it to write code to count the number of R's in a given word starting with the word strawberry. Now, if you write code that takes an input of a word and can count the number of R's within that word, it's always going to be right as long as the code is right. And for use cases like this, the model's ability to write code is actually much greater than its ability to answer these questions right without it. So here's an example. Write code to count the number of R's in a given word, starting with the word strawberry. Execute that code. And if we open up the analysis, so define the word, and it wrote code, and here's the output. And so it actually wrote code and executed code, and now I know it's going to be accurate. So I call that prompting using code. All right. To wrap this up, let's talk about some best practices. Number 1, provide examples. We talked about 0-shot, 1-shot, and few-shot. If you can, when you can, try to give your model examples, especially when you're trying to get consistent outputs. Design with simplicity. I really agree with this. Start with simple prompting and only add more instructions or more nuanced instructions when absolutely necessary. And anytime you're writing a task or a prompt for the model, try to think, is this the simplest version of what I'm asking for? Be specific about the output. This is really important. If you're expecting JSON, say you're expecting JSON. If you're expecting every letter of the first word of the output to be the letter B, make sure you say that. Whatever it is, specify your output, because otherwise the model's just going to try to guess what you're asking for. Use instructions over constraints. So an instruction provides explicit instructions on the desired format, style, or content of the response. A constraint sets the limitations or boundaries. So rather than saying, here's what not to do, say, here's what to do. Next, control the max token length. This is not something I do actively, but especially for higher scale production use cases, this is really important for optimizing the latency and the cost. And another note on high scale or production use cases is use variables. Use variables in the prompt. So here's an example. Here are the variables: city, Amsterdam. Prompt, you are a travel guide. Tell me a fact about the city. And then going forward, you can programmatically insert any city you want here. The last thing I'm going to suggest is stay up to date on all of these models, what their capabilities are, what the limitations are, because that's going to help you know how to format your prompts most effectively to get what you're looking for. Obviously, follow my channel if you're not already subscribed, because that's what I do all day, every day. Hopefully I can keep you informed. I also have a newsletter that goes over the same thing for future.ai. I want to thank Google and specifically the author of this document, Lee Boonstra, for this prompt engineering guide. It's fantastic. Check it out. I'll drop a link in the description below. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.